Le Chatelier's principle basically states that when a system is stressed, it will return to equilibrium. So a system means that the reaction is at equilibrium. It can go forward or it can go backwards. We have this example reaction here where we have nitrogen and hydrogen come together to make ammonia. And it could go in the forward reaction towards making ammonia, or it could go backwards towards the reactants, the nitrogen and hydrogen gas. So when I say stress a system, that means changing something. It means I can change the concentration of the reactants or the concentration of the products. I do that by like physically putting more nitrogen gas into the system, right? That would be adding more nitrogen gas. I could also do it by taking away nitrogen gas. That would stress the system. So I can physically do it by adding mass, right? More nitrogen, taking away nitrogen, something like that. I could also do it by changing the temperature. So this energy here sort of indicates the temperature. When it's negative, it means that the temperature can be added to the product side of the reaction. So for this one, we have N2 plus 3H2 yields 2NH3. And these are all gases. That is important, and I'll show you why later. But they're all gases, and then because the energy is negative, I'm actually adding it over here as a product. So if it was a positive number right here, I would add it to the reactant side. If it's a negative number, I add it to the product side. And so when I change the temperature, that affects the energy, and again, putting in more energy can change the temperature and have an effect on the system. Taking out energy can change the temperature and have an effect on the system. And then the other thing we can do is we can change the pressure or the volume. That only affects gases. So if you have solids or liquids in the system, it doesn't affect those. It only affects gases. And increasing and decreasing the pressure is another stress we can put on the system. So we can add or take away mass. We can raise or lower temperature, and we can increase or decrease pressure and volume. Those are the, I guess, technically 4 ways that we can stress a system. So what I'm taking you through here is the first example, and we're going to go through each one of these and how they affect the system. So if I add N2, so N2 is right here, right? It's one of my reactants. I'm going to increase N2. So the question is, what happens when I do that? Well, if I increase N2, then I have more reactants than I have products. So that means if I increase my amount of N2, I'm just going to put, I don't know, like an X here, because it's actually what I'm stressing, so it's not really going to give me an answer here. But if I increase the amount of N2, that means I'm going to make more NH3. So if I have more of this, it means I can make more of my product. So that means my ammonia is going to increase, and if my ammonia is increasing because I'm using that N2 to make ammonia, my H2 is going to get used up also, so that's going to decrease. And then which ways does it shift? It shifts towards the reactants. That's the direction I'm pushing it. Adding H2, so now I'm going to add the other reactant. Again, that's going to allow me to make more product. So again, I'm going to shift the reaction to the product side, to the right. And when I do that, it's going to decrease the amount of N2 because I need the N2 to react, right? So I'm going to increase that in order to make, or decrease it in order to make more ammonia. Adding ammonia, so now I'm adding more product. So when I add more product, I can find equilibrium by breaking that product up into its reactants. So my shift is going to go the opposite direction. So because of that, again, it's not really affecting that, but we're going to go increase the hydrogen and the nitrogen because I'm breaking up that ammonia to make those two. You can kind of think of it as like almost like a balance, right? Like if I have a little scale here and I'm dipping one way or dipping another, right? If I increase the amount of stuff on this side, right, it's gonna fall down. So in order to balance that back out, I need to increase the amount of stuff on this side, so I shift it that direction. So just visually, hopefully that makes it a little clearer. So removing N2. So now I'm going to take away N2, right? So now I'm going to take away N2. So now I have less on this side. So in order to even back out, so now I have less. So in order to even back out, I need to take away, I need to lessen my product. So when that happens, it's going to make the H2 more, and I'm going to shift this direction. So same thing with the H2. So if I increase, or remove the amount of H2, I'm removing H2. That's going to, again, make my reaction shift to the left towards the reactants because I removed it, so now I need to fill that hole. So that's going to make my ammonia go down and my nitrogen go up. Removing NH3. So now I'm going to remove NH3. That means I don't have as much on this side. So in order to even back out, I'm going to need to shift this direction. My NH3 is what I changed, right? But that's going to make my N2 and my H2 go down. Increasing temperature, the next two, 7 and 8, increasing and decreasing temperature. Well, remember we put temperature over here as a product because the temperature was negative. So that means it's going to be a product. So increasing and decreasing temperature is the same thing as like adding or removing ammonia. So increasing temperature means that I increase the energy. So if I'm increasing the energy, that means I have more products than I do reactants. So I need to shift back towards my reactants. So increasing temperature makes me shift to the left. And if I shift to the left, that means I'm going to have less NH3, more H2, and more N2. Oppositely, if I decrease my temperature, right? If I decrease my temperature so I have less products, now I'm going to need to fill that void, right? So I'm going to shift toward the right, toward the products, because I decreased my products, so now I need to shift that direction to sort of fill it back up. That's going to increase my amount of NH3, my ammonia, and it'll decrease my H2 and N2. And then finally, pressure. So I told you guys pressure only affects gases, right? But all of these in this equation happen to be gases. So then we have to take a look at the number of moles of gas on each side. So here I have 1 mole of nitrogen plus 3 moles of hydrogen. So on my reactant side, I have 4 moles of gas. And then on my product side, I have 2 moles of ammonia. So I have 2 moles of gas. So when the mole ratio is what I need to take into account here when I'm looking at pressure and volume. So for these last 4, it doesn't matter what those things are. We're only going to look at the moles. It doesn't matter what the elements or compounds are. We're going to look at the number of moles. So with pressure, if I'm going to increase the pressure, so I'm going to like take this box, right? And I'm going to increase the pressure. I'm going to push on it. So that means I'm going to take the moles and I'm going to push them together. So that means the reaction is going to go toward the side with the smallest amount of moles. So in this case, that's going toward the products. So if I'm going toward the product, that means I increase product and I decrease my reactants. Oppositely, if I decrease the pressure, so that means I'm letting off the pressure, right? The pressure is being let off. Then I can spread out, my molecules can spread out, and I can go towards the direction with more moles. So that, in this case, is toward the reactants. So that means my reactants will increase and my product will decrease. And then if you take a look at how I drew this box, it kind of works for volume too. These blue arrows are the same thing as increasing the volume if I made the box bigger. So actually increasing the volume and decreasing the pressure are the same thing. It's having the same effect. So again, it's giving them more space for moles to exist. So it's going to tend towards the side with more moles. That means I will increase my product or my reactants and decrease my product. And then finally, the last one, decreasing volume. Decreasing volume is the same thing I drew there in those black ones, but there were red arrows on here. Decreasing volume is the same thing as increasing pressure. These are the same thing. So I'm pushing the molecules together. When I do that, I'm going to create less moles, right? I'm taking my 4 moles and I'm pushing them together to make 2. Because I'm decreasing the volume. I'm making the box that they're existing in smaller. So by doing that, I'm pushing the reaction toward the product side. So when I push it toward the product side, that's going to make my products increase and my reactants decrease. So there I did the first example for you. There is another example in your notebook. Hopefully you followed along, and the next example is for you to try. Let me know if you guys have any questions.